Here we go. Hello, hello. Can you hear me? Yeah, all right. So, hello again. This is episode 2. My name is Andrei Viktorov and I will be guiding you through this live stream session. Today we are going to create a project based on third-person shooter demo, and we will have some fun and we will use it with interactive objects with physics. Alright then, all we need to do is to download the latest SDK. I have 2.12.0.2, and you will also need to download the third-person platformer from demos. It's located in samples, demos, and then you can find it here. Alright, so the first thing we are going to do is we will create another project. For this purpose there is a specific button here. It's called copy as project, so let's try it. So here we have like the standard parameters that we can enter. We can select where we want our project to be located and what the project name. Let's call it Livestream session. Oh, I forgot to switch to my desktop. Oh my god. All right, so you haven't seen anything. Okay, so right now, so let me do it one more time. So let's open up the SDK browser. Can you see my desktop right now? I think you should see it. Say something like a plus or minus if you can't see it. Okay. So you will need the to download the latest SDK. I have 2.12.0.2 and you will also need to download the third-person platformer demo. It's located in samples, demos, and here you can download the C# third-person platformer. There is a specific button if you want to make a project based on specific demo. It's called copy as project, and let's click it. Here we see all the default parameters, and let's change the name basically. Live stream session 2. This is fine. This is also fine. Yeah, we need to select the C#, and we are fine with the float precision as well. Okay, let's create a new project and then we will have a look what's inside. Hi there. Hi. By the way, if you have any question, feel free to ask and I'll do my best to answer it. And we have another project from the previous session. Hello, Mansoor. All right, let's have a look. So this is the complete demo that shows how to create third-party shooter based on C# component system. Is there any games or project made with UNIGINE? Yes, of course. There were a few games that were previously based on the first version of the engine, and there is another game. It's called Dual Universe. It's based on UNIGINE 2 point something. I forgot the version. All right, so let's have a look. We have like a little map here, and we have our player. We have some obstacles and enemies. Let's launch it and see how it plays. And I'll probably need to make this a little bit. Yeah, I need quieter. Yeah, is it too loud? I guess so. So here yeah, it is too loud. Yes, yes. Let me run it again and lower the volume a bit. Here it is, like so. Yeah, much better. A bit more. Okay, fine. Alright, so what we have here? We have a simple third-person shooter demo. I can control my character using WASD keys, and I can shoot by left mouse button. Pretty basic stuff, and there is a simple health system. If I contact this, I will be damaged. Let's jump inside the lava, see what happens. Okay. Okay. Alright. So that's what all we have here now. So what we are going to do with this? First of all, I will show you 3 specific physics objects that can solve very specific tasks. We are going to use ropes, we are going to use cloth, and we are going to create destructible objects. That would be the first 3, and the last one will be explosive barrel. Right then, let's try some simple stuff and create destructible objects. Alright, so first of all, let's create a folder for where all our physics object will be placed. Physics objects. Let's call it so. And by the way, I will not go into details about the source code right now, but if I will touch some component, like built-in component, then I will explain it to you. Can you do one where you can switch from FPS to third-person shooter like GTA 5? Of course, it's a general-purpose engine. It's not tailored for third-party or first person. Like you can build any game on it if you want. Alright then, let's create a simple barricade. Let's create like 2 by 1 by some point something. Let's create a primitive. First we go to the create tab, primitive, and then box. Here we leave 1, here we leave 2, and here we leave point something. Let's point 2. Yep. So the first thing that you need to know about these 3 physics objects is that they cannot work with object mesh static, so you have to create object mesh dynamic first. And luckily we have our mesh created for us, so it should be no problem with this. We go again to create mesh dynamic, and then we select our box. Here it is. Alright, Yeah, let's make it fun first, and then we will work on the visuals. All right, so in the physics tab, when you select this object, you can select. Oh, I see the problem. Let me move it here. Yep. Like so. All right, so fixed. So in the parameters, in the physics tab, you can select which physical body this object will be. And we are interested in this in the object called fracture. Here we have a lot of parameters, and I'll explain it later as I go with this object. So basically, this means that this object can be destroyed and split into several physics objects. So the engine do like the splitting part for you, so you don't have to do like the complex math. All you need to do is to make a few API calls. All right, what can we do with this? Basically, it's by default it behaves almost the same as the typical rigid body objects. See, it's affected by the gravity. You can interact with it. So we're very basically the same. But here goes the magic. In order to interact, in order to split this object, we are going to write some code. And for that, I need to go to the script part. And it should be in the components. So we are going to change how our bullets interact with this object. Let me first show that it does nothing if we try to shoot it right now. So yeah, like no fractures, no destructible objects yet, just simple impulses applied. Okay, let's go and write some code. Here we have a bullet component, and it basically defines how our bullets, like in-game bullets, will behave. So this component is assigned to this prefab. So if we go into details, we can see that this node has this component assigned, and thus it's affected by its logic. So if we change this component's logic, we will change all the bullets. Durable, something like asset store or marketplace for UNIGINE? I think yes, but I can give you any details about it. All right, let's do some coding. So the bullet logic is very straightforward. So we have the current bullet point and the next point where it might be. And what we do is we check if there's something on its way, and if it is, then we destroy the bullet, we create the heat effect, and we apply some impulses. And here all we need to do is we need to get this body fracture. Let's call it body fracture. Object body, and here we will cast it to body fracture, like so. Let's keep it. Destroy fractured objects. And if we have this body, then we will call a specific method called create shatter pieces. It's basically this method will split our body into several little objects. But if you leave it like so, without with the default settings, you will probably, you won't notice any difference. Let me show you. And maybe you will. Let's find out. I want to explain to you something. See, no fracture yet. What we need to do is we need to configure this object. So let's go to the this object. Let's go to the physics tab, and what we are going to do is we need to lower this threshold, because this threshold defines what is the minimal amount of volume that is allowed for a single crack piece. Let's keep it like so, and let's play again. See, now it's destructible. All right. Let's try to make like the exact, like the real barricades for the gameplay. Let's try it like so. So the one thing that you might notice is that these objects are still allowed by all default physics. So if we want to fix them at some point, we have to use joints, and I will show to you how to do this. Let's call it barricade. Let's make it prefab actually. Not here. In the physics objects, let's drag it here. So we have a barricade. Let's duplicate it and rotate. So if we leave this objects like that, then this is affected by the physics engine, and this is not what we want. So how can we make this object stay in its place? Well, there is no settings like with the rigid body. We can't set it immovable yet. Developers, if you are watching me, then please do this. Alright, so in the current version we are going to use joints. So let's create another object. It's located in physics and it's called object dummy. Let's add it here. Let's add it inside. Let's actually, alright, let's call it barricade fixed or static. And we will change this object body to dummy. That means that it might be used to connect bodies with joints, but it does not do any physics interactions. Right. And here, yeah, I would like to change this hierarchy like so. Can I do this? Nice. Right. Let me reposition this, and then I can also reposition it like so. Okay. Now we need to connect this object to this static physics object. We are going to use a fixed joint for that. Let's hit add and then select barricade static. Let's hit save and see. Now it stays on its place. That's what we wanted. So currently all these barricades will be like static barricades. Let's rename it as static. And let's have a look. Oh, crashed. Okay, let me run it again. Okay. Now we can have some simple gunplay with barricades. And the cool thing about it is that we can apply this simple object to make like very complex gameplay. For example, we can create another enemy with some sort of armor plates attached to them. Consider touching and create some in-wall armature, please. How do you do this? Joints. What do you mean by armature? Do you want to see like how to destroy these walls and see some like internal armature inside? Do you want that? If so, I think we can it can be just a bunch of static meshes placed inside, like this, for example, this barricade, which, but not the visuals, physics exactly. You want to use physics engine to simulate like the entire building and all these joints. I think that's, for that purpose, you will have to create your own physics simulations that's designed for the like for the buildings. And like if you are talking about some sort of a bridge simulator kind of game, then it's usually a custom-made solution. So these physics they are mostly used for the visual effects and like juicing some gameplay. If you want to do real simulation based on that physics, then you will it's not a suitable solution for that. Right, so now we have a simple fractured bodies which we can use for to improve our gameplay. And we can apply some sort of armor here. So instead of taking damage, we have to first like destroy the armor plates, and then and only then we can destroy the turrets and enemies. And you can always use them as like static covers. Okay, so what we are going to do next? I'm gonna show you the how to create ropes, and we will create a simple bridge. Let's say we want to connect these two walls with the bridge, just to add some add more variety to the gameplay and add shortcut. For that purpose, we are going to use dynamic meshes, and we are going to use another body that's called body rope, and I will show you this in a minute. Okay, any questions about this object fracture? I think this was really straightforward and simple. And now we are going to more complex task. And before we go to the more complex task, I can answer a few questions. No questions? All right, let's move on then. So the next thing I want to show you is how to create ropes. You can use them for many sort of visuals and physics simulation, and for our needs we will create a simple bridge. Let's create the rope geometry first. I'm going to create a simple cylinder. Let me calculate how much of this rope I need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15. Okay. let's change the diameter to, let's say, 0.5. So this will be 15. So we need, so stacks, that mean the the number of cross sections across the cylinder, across its height. We need a lot of that. Let's say 100. And slices, that means the amount of sides. 8 is fine for us. Let's see. Okay. Let's see if it fits. Yeah, nice. Okay. Again, we can't use body rope with object mesh static, so we are going to delete this mesh static and we are going to create a mesh dynamic. It's based on our cylinder. Yes, this one. All right. So first, I want to show you what this rope looks like. So the way the rope simulated is it splits all the geometry into particles and it connects every particle by joints, and it does it internally, and it does it much more efficient if compared to, let's say, like manual rigid body setup. But as a limitation, it works only with object mesh dynamics. Let me show you how it looks. And by the way, if you want to see all these physics-specific stuff, you can do so by going to the where it is. Oh yeah, here to the helpers, and then physics, and then, for example, if you want to see all the physics shapes, then click shapes and joints. So shapes and joints are fine for us. We don't want to see anything other than that. So now you can see that this yellow line here is joints. So these particles, there are a lot of particles here, and all of them are connected by joints. So these yellow lines. All right, let's see how it behaves. Rope 1. Just simple free fall. Right, looks like a rope. Okay. What we are going to do next is we create another rope. Let's duplicate it and place it somewhere here. Let's make a wide bridge. Like so, maybe. Yep, something like that. So if now we need to fix both ends of the both sides of the ropes, and we are going to do this by using another joint. First, let's create a like a simple cube, like 0.5, 0.5, 0.5. Let's name it as a like particle, like bridge stand. I don't know, let's name it so. And we are going to use basically we can go with body rigid and set its immovable flag, or we can use body dummy with the box shape attached, and then we can use joints. Let me create another cube, like so. Okay, so which joint we are going to use? We're going to use joint particles. So it works really simple. Basically what it does is it tries to find any particles from body rope or in the future body cloth that intersects this volume, and it sets flag that this particle cannot move. That's all what it does. How is this a rope 1 or 2? This is rope 1. Okay. Let's stand 1. Okay. Rope 1. So in this joint settings, the most important thing is its volume size. So we need to adjust it to the cube. Oh, and another thing is make sure you add this joint from this box, not from the rope, because otherwise you will have to set joint anchor manually. Okay, let me show you how it works now. Yep. So yeah, the rope is fixed here. Let's move it a little bit further. And as you can see, like this joint fixes these 3 points, so we will need to recreate it. Let's create it again. 1 0.5 0.5 0.5, like so. And see, yeah, now we have what we want. And let's create another one. Move it somewhere here. Yeah, this is a little bit longer than I expected, but okay. All right, let's try to fix it like so. .2. Okay, row 1. 5.5.5. All right. Let's see how it looks. Yep. As you can see, we fixed this row. So let's play with the physics parameters. Why not? So the most important thing for the rope is the linear stretch. It defines how far each particle pair can move apart from each other. So if I increase this value, you see it becomes longer and longer. If I decrease this value, so yeah, it tries to keep the distance between particles as short as possible. Another important parameter here is rigidity. Rigidity means how hard is to move every particle and how hard they move if they are affected by some force. So okay, I need to attach some object first and then I can show you. And maybe we need to make it shorter because this, yeah, we will need to make it shorter. Let me create another cylinder with 14. Okay, let's rename it like so. And then I will create another dynamic mesh. Yep, that will be much better. Let me delete all those ropes and rope 1. All right, that's fine. Not cloth, rope. Okay, and then let's fix this. Let's remove joint particles and then rope 1 and do it again. Okay, let's see if we did everything correctly. Okay, that's fine. And let's play with the linear stretch to make it even shorter. Let's play with the rope mass. No. Okay. I think we might try to make this even shorter, but let's add physics object first and then we'll see. Okay, let's create a simple box like 1 by 2 by 0.2 maybe. This will act as a simple bridge part. Let's call it so, bridge part. This will be body rigid. Let's add it somewhere here. Let's add box shape. And let's also attach it to the rope. And in the size, let's change it properly. 0.2. 1, 2. Okay. Let's see. Okay, this works. Let's play with the rope again. Yeah, it's still too long. Okay, let's build another objects and see. Like bridge part 1. Control D. I will do like very basic setup for the bridge I will also duplicate these ropes and see if it has all, yeah, it has all the particles, so that's nice. And all joints are here, so we're good. What else? Yeah, we will tune rope parameters later. Now let's focus on this, guys. Okay. So for each of these, we are going to create two particle joints. So 1, 2.2 for the first rope, and for the second one, 1, 2.2. And next, next object, 1, 2.2, and for the second rope, 1, 2.2. Let's see that we did everything correctly. Okay. And then here, body rope 2. It will be my rhyme, like 1, 2.2, because I will be speaking it like through the entire stream. Okay, 1, 2.2, and again. Sorry, this should be much lower. By the way, threshold is how far particle can be from this volume. So we might need it, especially if there are some particles on the close to the surface of this joint. A few more. 1, 2.2. And next one, 1, 2.2, and another one. Yeah, I want like a multi-edit with joints. It will be much faster if I can select all those objects and have the multi-editing support for them. But it's fine, it's fine. Let's finish our bridge. So this is correct. And the last one, let's move it closer to the entrance. 1, 2.2, and the last one, 0.2. Let's see how it looks. Okay. And now let's tune our ropes. Let's increase the linear damping and rigidity. Oh, and I actually forgot to tune the rope radius. Yeah. Like 0.2 maybe. Yeah. Yeah, we definitely need more shorter ropes. Yeah, we can increase the number of iterations. Yeah, like so. Yeah, we need to also fix this jittering. Let's see how it allows to. Yeah, so if we increase the rope mass, then no. LOL, yeah. That's how you usually work with physics. You try to build shapes and then fight with joints and physics settings. It's fine. What if we increase iteration count, like maybe 2, 5, 4, 3. Yep, that's better. We still have some jittering here. But other than that, I think and let's see what we changed here. We changed the iteration count by 2. We changed the rope radius. It's basically how large these particles can be. What else? We changed rigidity. That means how stiff our rope is. We didn't touch friction and restitution because we are good with the default parameters. It's like how, when it hits the ground, how it will behave, and it's fine for us because at this moment it never hits the ground, so we're good. So linear damping is how the velocity is decreased by time. Linear stretch is basically how long our rope is and how long can it be stretched. And these two parameters, this is the most exciting parameters, and we are going to use them with our closed system, and those two parameters means how far we can move those like each particle pair apart from each other before the joint breaks, like how far linearly and how what the maximal what is the max angle before the joint breaks. That allows us to make destructible ropes and cloth, and for example we can make destructible bridge as well. And I think I need to add more particles here, because like I have these two and these two and all of them are fixed. Yeah, I think that's the main trouble. By the way, let's disable physics simulation and go back to our settings and set this to 30. This is 0.2. Rigidity is somewhere here. Linear stretch lower, and add some damping. Let's see. Nice. See, no more stretching. We are good. And maybe rigidity is a little bit more too high. Let's set it like 2.2. And let's try and move across that bridge and see if we can do so. Okay, it's crashed again. where it is, where it is. And yeah, we fall under the bridge because these things are very light and we need to make them heavier. We can do so by selecting all of them and selecting shapes. We can multi-edit shapes, so that's nice. Let's set it to something like 30. And maybe even more, and then we will fine-tune the rope mass as well, like 50. Our player mass is like default mass is 30, so we will make this heavier than the player's mass, and then we will adjust rope's mass like 150 maybe. Let's see. No, still not enough. 250. 500. See, it's not like a real values. There, you can't use a rope that with the like mass that contains like 1 ton of mass. It's really heavy for the rope, but it's fine for us, because we are not going to use like real world values for our physics, because we want to make it look good. Why it's crashing? Almost every time. That's interesting, because before the stream, when I was preparing, it worked very smoothly and perfectly. Like no crashes at all, and I did much worse things than I do on live stream sessions. Okay, so we have a bridge, and we can move across it. So that's good. Okay, nice. And one more thing regarding ropes, and if you want to like make these ropes breakable, then you can set linear threshold to some value and see if it breaks. If it doesn't not break, you can play around and see, like try to move, like to do like extreme stuff. See, it broke here and here. We can do the same with other rope. So that way you can add more variety to your gameplay. For example, you can create destructible ropes and yeah, basically you can have destroyed passages, or you can have like specific triggers which will destroy ropes. Why this does not break? Oh, because I haven't set this. Okay. Let's set this threshold to some value. Okay. Why it's crashing every time? Oh, right. Fine. And the thing is, if we try to shoot this rope, we won't be able to do any damage to its internal physics system, because if we have a look at the bullet logic, it only affects rigid bodies and fracture bodies. So we need to invent some sort of way to affect other body types. And we will do so when we will add cloth to the game. Let's actually do this. And let me first move this into another prefab. Let's create no dummy. Move it somewhere here, maybe. And move all this stuff here. And call it bridge. Yep. So now we have bridge prefab and we can reuse it everywhere we want to make additional passages. Let's try something cool. I need to disable the snapping tool so I can rotate it properly. See if I can do something like this. Let's simulate and see. Almost. Let's move it a little bit higher. Yep, like so. No. Maybe we can connect it like so. Yeah, that looks much better. Okay, nice. Let's go and play. Okay. I want to cross that bridge. Okay, cool. So we have added 2 additional passages to our level. So that's nice. And we have additional covers which can be destroyed. And by the way, you can define the material for the cross section of this cover. If you go to the physics settings, to the body fracture, it allows you to define the to set the material name for the cross-section parts, which is nice. For example, you might have a specific material with, I don't know, like concrete, like tiled concrete, and then assign it to this body fracture, and then you will have like a concrete on the cross-section. And all the external parts will keep the original material, but all the cross-section parts will have specific material. Let me show you. Let's create a simple mesh-based material, like let's call it red. And then we will change the albedo to red. And set the cross-section part here to red. And see, the cross-section now is red. So now you can fine-tune the visuals if you want. Yeah, it's actually more fun to play that way. Like I can create an additional passages here with barricades, and I can add specific goal on that part because it looks like so nice. Right, let's go to the third object, the cloth object. So for the cloth object, we also need to create an additional geometry, and we also can't use object mesh dynamic, object mesh static. Let's create the geometry first. We need to create a plane. Let's say we want to hide this passage, and we need to 3 by 5. Let's create a plane. 3 by 5, and let's keep the segments high. So we have our cloth geometry, like so. Let me enable snapping back. So we can create secret passages. That's hidden with the cloth. Yeah, now this game looks more like Indiana Jones meets robots. Because of the bridges and clothes, and if we change the visuals to more like adventure-esque vibe, it might fit much better. And maybe I need to do this a little bit smaller, because just a little bit less, so I can avoid the intersection with the level. Yeah, let me recreate the geometry. Let's make it a little bit shorter. Like 2.9 and 4.9 should be fine. Yeah. Okay, nice. Cloth 5 by 3 meters. And let's create a cloth material right away, because we will need it to be two-sided. And then we can assign it to let's create a mesh dynamic first with our cloth geometry, then we will orient and move it properly. And then we will assign the cloth material to it, so we can see our cloth from both sides. Okay, that's nice. And then we're basically gonna do the same that we did with the bridges. We will create, basically we will use the same geometry, like barricades, like where this should be, like stand, or let's call it stand. Is it possible to create a competitive online game in UNIGINE? And if it's possible, what's the limit on the amount of players you can support concurrently? There is no network that's tailored for the online games out of the box. You have to use your own solution for that. Other than that, it's completely fine, because, for example, there are guys who do Dual Universe. It's a massive online multiplayer game where you can move from one planet to another, and you can craft things, and you can change the terrain and build things. So that's basically proves that it's possible to use UNIGINE for that type of games. Okay, let's drag two stands. I don't know how to properly name this, like fix up, stands. What's the word for this kind of things? let's assign body dummy, let's assign boxes, and for that we'll assign cloth. And here you can see how basically body rope and body cloth work. They create a lot of particles at each geometry point, and then they connect them via these joints, and then it's basically a mass spring system which body cloth internally solves. If you want, you can apply forces and impulses at each individual point if you want, but I don't recommend you do so, because first you need to locate this point and then you have to calculate some sort of impulse, and there is a physics engine that does this for you. Let's see how it behaves first without any settings, like with default settings. Not great. Let's try to, let's disable this and see if it will behave. No. Okay, then let's increase the iteration count, see how it will look. Okay, better. And of course we can change the linear stretch. That basically defines how, you know the answer, like how far these two can be apart from each other. And of course we have the same settings for the clothes as we fine-tuned with the ropes, and we need to adjust those settings. Let's fine-tune the radius of our particles, like so. What else? We can increase rigidity, maybe linear damping, and reduce the linear stretch. So now we will have, and we can check the two-sided option for the cloth, so we can interact from both sides. Okay, let's fine-tune this. Reduce 1.2 maybe. 1 should be enough. A little bit rigid. Frictional restitution is fine. Linear damping a little bit. Linear stretch. Okay, that's fine. Let's see. Okay. Looks better. All right, let's enable our stance back and add joint particles. Basically, you know what we are going to do. 0.5, and here also 0.5, and we are going to do the same here. 0.5, 0.5, 0.5. Okay, let's see. Nice. Let's play with the cloth and try to increase the threshold, like to 1. No. Like 0. Okay. Let's increase it here and run the simulation again. And now if we try to move our stance, we can tear it like our clothes apart if we want. So that's what we are going to do with the clothes. So let's play and see how we can interact with it, and then what else we can do. Let me restart the editor, maybe it will fix the crashing issue. Should work fine without it, but looks like my stream software might affect it, because when I was not streaming it worked perfectly. So don't worry, it's much more stable than it looks. Okay, so let's hit play. Okay, let's hope for the best. No. Why? Let's make this to 1 so it's not really stretched. Please. Chrome eating too much RAM. Let's see without it. Maybe it's related to cloth. No. Why it's crashing? Let me do another trick. Let me try to launch it from Visual Studio Code. I will do. Let me go to the project folder and let me copy the binary name, like Livestream session. Cool hacks here. Okay, and now I can launch it from here. Let's see if it will work. No. Okay, what did I do wrong? I'm currently on a game and what I tested UNIGINE is fine with 200 characters in one scene in offline mode. But this is heavy. Depends how much optimized have the models are, animation control network code. Of course, yeah. It really depends on the amount of like on the visual fidelity, on the feature set. It's really can't be really that complex. Let me try to launch it in release and see maybe if it will launch. No. Relax, bro. Maybe it will launch if I delete the clause like at all. No. Okay, we've just encountered like a. Okay, let me save the world and try to launch like previous project. Try closing Chrome. Okay. But I have a lot of RAM here, so it should be no problem. Let me try to launch it from. This is actually the project from the first session. Okay, it launches fine. Let me launch this project again. No, doesn't work. Let's disable all things we did except clothes. Maybe it will work that way. No. What's wrong with this project? Let's disable. Let's actually delete it. I'm just curious now. Now I'm curious. Okay, this works. So that's fine. So we messed something up with the physics probably. Let's delete this and see if that way it will work. Okay, fine. Fixed. Okay, so now we can only interact with these clothes like so, and we can. It's not affected by the bullets. We can't do anything. So let's fix that, because it's that way. It's kind of boring to interact with the clothes like so. I want to hit it with the bullets. I want to make holes in it. So how we are going to do this? There is a specific. We have two ways basically. First is to go to the bullet logic and then like get body clothes, obj body as body clothes, and then we can do like so, add particle impulse at some particle at some impulse. But that will require us to find the position, find the particle, calculate the impulse, and then apply it, which might be a little bit too much, and it might not perform very well. So instead of doing that, we will go another way. In UNIGINE, there is a specific object. It's located in physics here. It's called physical force. So the way it works, it basically allows you to attract all or detract all physics objects to a specific place, or from the specific place. Let me show you. Like so. If I enable attractor, see? Oh, that was too much. But you get the idea. So I have the object that can apply forces implicitly to every physics object. And the way I want this to work is like so. I want it to be like a small radius, like 0.2 maybe, like so. And I want it to hit really hard. We are basically going to emulate how impulses work with this. So I will disable this first, and then I will intersect it with the cloth. Like so. And then I will enable it for a short time. Like, I missed it. Like so. And then enable it. And there it goes. So that's how we are going to interact with our physics objects. So all we need to do is to spawn this thing for a short period of time when we hit this with the bullet, like so. And there, so that way we'll have this hole in our cloth. So let's do this. So that's the idea. And this demo, it already has some built-in components, and we are going to use one of them. It's called destroy. Basically, it automatically destroys the object after some time, and we need this to live like 0.2 seconds, and we are fine with this. Let's call this bullet physic hit. And we are going to move it here as a prefab. So we have this node. And then we are going to add additional parameter to our bullet. We'll call it bullet physic effect. Or hit physics, or hit physics effect. That's better. So when we hit body cloth, great engine ever, cloth without any vertex paintings and make a hole with a simple physics. Yeah, it's really that straightforward. So let me show you body cloth. If body cloth is not null. That means we hit our cloth, and what we're going to do is we need to spawn the object. How do this? We create hit physics, and there is a singleton object called world, and it allows you to load node. Basically instantiate prefab, if we will speak in Unity terms. Alright, so we created this prefab and we need to position it. Let's set its world position to where the intersection is. That's it. That's all. Let's save and play. No? Not yet. What did I miss? Oh, of course, I forgot to set the prefab. Okay, let's go to the bullet prefab and let's set it to its bullet physics here. Okay, let's save it. And let's play again. Now we have pellets that can make holes in our cloth. Maybe that's a little bit too much, but we can fine-tune the amount of this effect by changing the prefab. That's pretty cool. Yeah. I also like that part the most, because like, oh, I can do holes in clothes. That's so nice. Let's change this prefab a bit and make it maybe a little bit smaller, like 0.5. And the cool thing is we can test this before we hit play. We can all we need is to simulate the physics. Oh my god, that was too much. Let's decrease the attractor amount. Yeah, that looks nicer. Maybe a little bit more, like 20. Yeah, nice. Okay, let's play. And another thing is that we don't need to destroy our bullet if we have body cloth, because we want bullet to go through this cloth. That's a little bit of gameplay touch, so it feels nicer. Yeah. Okay, so now we have Borderlands 4 with NVIDIA physics enabled. I'm joking. Yeah, that's how you do it. And we can also add some destructible objects on the walls, and it might look much more fun and feel much more fun. All right, what else do we need to do? Let's create the last object. Let's create the explosive barrel. And for that purpose, we will create another cylinder. Let's keep it like 0.7, 1. We don't need a lot of stacks, so let's create like 32 slices. So we'll have a nice looking cylinder. Right, let's assign red material to it. And I have a specific texture. I downloaded it from somewhere, from the internet, basically. It looks like so. Let me show. You can't see it. Now you can see it. So basically, it's a simple explosive sign with the transparency, and I want to add it as a nice touch. So the thing is that I'm not an artist, and the way I do it, I not recommend you to do it in your project unless you want to build a quick prototype. Okay. So the way I will add it to this barrel is by using decals. I mean, you can use decals to decorate objects. It's totally fine, but I think for the barrel itself, it's better to put the texture right to its texture, like the explosive sign to the barrel's texture. It will be much better than decals. Okay, let's fine tune this like 0.4, 0.4, maybe 0.5. We need blueprint system for simple people like me. Yeah, blueprints are nice. Okay, so we have like first sign. Let's call it sign 1. And this barrel. And let's create a child material. Let's call it explosive sign. All we need to replace is the default albedo texture with the sign texture. Here we go. And I need to rotate it as well. Okay, let's rotate it. Okay, so now we have a nice looking explosive sign. So it's good for a quick prototype, but really don't use it in the production code, please. Please don't use it. And let's create another one from this side. All right. And for the barrel, we want to use rigid body. It's really familiar for the most of you. Not capsule, let's create a cylinder shape. And let's fine tune it. We want radius to be 0.35 and height is good. Okay. Let's see how it behaves. Oh, maybe we'll need to adjust its mass, like maybe 50. Let's see. Yeah, that feels nice. Let's... Oh, and by the way, there are no decals here because they are default, but disabled by default in this demo. Let me enable it. I can enable it from the console, like so, decals. So now I have decals for my bullets and for the explosives. Okay, good. Let's create a simple C# component here. Create C# component and let's call it explosive barrel. So what we want to do this with this script, we want, first of all, we want to, when it's destroyed, we want it to explode. So the way it explodes, it will be doing 3 things. The first one, it will create an explosion effect. And we have one in the particles, particle explosions, explosion node here. We will use the same explosion effect for the robots, turrets, and explosive barrels as well. So it will look like so, with the shock wave and sparks and stuff. And the good thing that it also has a sound source inside this effect, so it will be automatically played. So that's nice. So we don't have to care too much about the sound. Alright, so we need to have the additional parameter for the heat effect. And by the way, I didn't explain these attributes to you. So the first attribute will show the private variable in the property settings. Let me show it to you. So if I go and assign this script to this node, then it will show heat effect here. But if I don't use this parameter and this will be private variable, then it won't be shown here. See? So that's the first thing. And the second thing, it tells the editor how it should be represented to you. So here we have parameter file, which will allow us to select the file in the ASCII browser. And here we can have additional parameters like tooltip, like what will happen if we hold the mouse cursor under the parameter name. And another thing that we can have here is filter. We can exclude some other asset types from being selected. Like we don't need to assign a material here, right? So right now we can have right now we can only select nodes. So let's drag it here. Okay, so we have our explosion here, which is nice. And how we are going to destroy this? Because if I will try to just shoot it, it won't do anything. So this particular demo contains another component that we are going to use. So we already used destroy, and now we will use a health controller, because it does everything we need. Let's assign a health controller to this, and let's say we need like 5 hits in order to so this barrel will explode after it will take 5 hits from us or from someone else. Right, let's create a health controller here. Let's get a reference to it here, health. And the way we get the components are basically the same as we work with them in Unity, for example. Instead, with the one exception, we have to. Can we use get component here? Maybe we can. Let's see if we can do so. Can we do so? No, we can't do so. So we have to do it like this. So node is a built-in variable. It's basically a node that has this component assigned. So we can fetch and get another components by asking that node to give us some controllers. And if we have our health controller, we are going to do a few things. First of all, let's go and have a look what's inside this health controller. So it's really simple. So it contains public property called health points, and it also contains 2 events. So the first one is a changed event, when, for example, we can do certain reactions when our game object is hit, and we have another event for object death, and that's what we are going to use. Let's do it like so, explode. Let's add another method. And we also need to make a shutdown method, because we also need to remove the event handler, like so. And instead of update, we will have another method. We'll name it explode. And here, what we can do is we can create this effect, like we did with the bullet. Let's call it VFX. And let's position it to the node world position. And let's destroy our node. We can, again, we can have two ways to delete the game objects. We can delete it instantly, like force, or we can delete it later, maybe on the next, at the end of the frame, or maybe on the start of the next frame. So it's better to use delete later if you don't need to destroy it right now. So that's our simple explosion barrel logic. Let's see if it works. So we have a health control and explosive barrel. We have a hit effect assigned. Let's move it closer to the player. Maybe here. And let's go and play. Okay, so right now it exploded, but it didn't do anything. All right, let's go and make a prefab first, so we can reuse the same object. Let's go barrel, and maybe we need to organize this like meshes, nodes, materials. Let's move this. What else? Not mount. Textures. Nodes, mesh. Why can't I move? For some reason I can't move. Okay. Let's finish that prefab. So the second thing we need to do with this barrel is we need to add impulses to all rigid bodies that's around this barrel. So in order to do this, we need to do two additional parameters. The first one will be, let's call it blast radius. Let's show an editor and parameter. We want it to be displayed as a slider. And the same thing goes for the, let's parameter. I think we don't need to assign a parameter here. Blast impulse. Let's give it some big value. So here we need to first create a visual effect of explosion. Second, apply impulses to all rigid bodies around. How we are going to do this? So we have a world get intersection. So we have a few methods here. We are going to use the one with the that takes bounding sphere and returns us the collection of objects. Let's first make a list of objects. Object. And then let's create a bound sphere. Blast sphere. So it takes two parameters. The first one is the center. It will be our node center, world position, and the second parameter will be blast radius. Okay. So here we will pass blast sphere, and then we will get the object list. And then for each object, we will try to get its rigid body. Audio rigid. If it's not null, then we will apply some impulse. Add world impulse. So we have a point from where we need to apply this impulse. It will be the object world position, and then we have the impulse. So first we need to calculate the direction. It's very easy. We will subtract our barrel position from the object position and then normalize and use this as a direction. So we have direction, and now we need to multiply it by our blast impulse. So that way we will apply a world impulse to our rigid bodies. Let's go and see how it works, if it does anything at all. Okay, blast radius 3. Let's try to destroy this. Nothing really. Maybe let's increase the blast radius to, for example, 10, and blast impulse to some extreme value, like 3000. Okay, that works. That definitely worked. Okay. Okay, that worked. And the last thing, the third thing we need to do is we want to this barrel affect our other object like claws and ropes and barricades as well. So how we can do this? So see, if we try to explode our barrel, it does nothing to our cloth, which is not nice. And the way we are going to fix that is the same way basically as we did with the bullet. We need to create another explosion, like physics hit effect. Let's duplicate it and rename it barrel physics hit. Actually, I have different naming conventions here. Let's rename it barrel physics hit, and the same with the bullet. Okay, that's fine. Let's drag this one and let's adjust its settings. First of all, we definitely want to reduce need to be bigger. It doesn't have too much this blast radius. We can fine tune it. Let's try it. No, that's too much. That's definitely too much. Let's keep it as a 3 maybe, or maybe 4. Let's increase the heat to 100, for example, and let's also increase the attenuation. So the way attenuation works is basically it reduces the force as distance between physics object and physical force increases. So if it will happen like here, in the middle of the explosion, it will hit with the all force. If it will be in the middle, it will be 2 times less, and here it will be near 0. Let's see. Let's. Oh my god, that was really high. Let's increase the attenuation. Yeah. Let's make it a little bit yes. So it might hit like so. Nah, still too much. Let's keep it as 50. Still too much. And now I can change the attenuation. I think, no, too much. Maybe 4. Yeah, okay, let's keep it like so. And maybe decrease the radius a bit. Okay. Okay, so the last thing we need to do with the barrel is to create the physics heat effect. Heat physics effects. And let's also create it. Create a physics effect of explosion. How should we name it? PFX? Okay, let's name it PFX. Load node heat physics effects. PFX world position, node world position. That's it. Okay, let's go to the barrel prefab and assign barrel physics heat here. Okay. Now let's go and play. Okay, that definitely worked. Okay. Nice, nice. And maybe as an additional logic we can apply damage to the player and enemies. Like here. Apply impulses and add damage. We can have another variable. Plus damage. Let's keep it like 5 maybe. So health controller object get component health controller. If it does have it, then we will apply some damage. Health, take damage, blast damage. Like so. And actually, one more thing we need to do is we need to, for example, if we keep our barricades here, like so. Oh, looks like barricades are working not that well. Okay, we found the problem. So okay, let me try to extract the physics object itself. I don't care if it will be static or dynamic. I just want it to be working. Okay. See, like this, it doesn't affect the body fractures, and we need to change that as well. So we also need to change for the body fracture here. Body fracture, object body as body fracture. Then we will split it into create shatter pieces. And here we can have like a additional logic, like how far this barricade from the explosion, and we can create less pieces, but we will just create 7. Okay, now this works. Okay, so we have an explosive barrel, we have destructible barricades, we have a destructible cloth, and we have bridges. Let me put back one of our bridges. And let's hope it will work as expected. Okay, nice. So that way we can improve the gameplay of this demo a lot by using physical objects, especially clothes and like complex interactions with the fractures and with the... oh my god. Oh wow. What was that? Okay. I can't even quit. That was unexpected. But you get the idea. So I showed you how to create 4 objects with different physics bodies and different physics calculations, how to use joints, how to connect all these interactions together by using physical forces. I think that will be it for the live stream. Let me switch back to my talking head mode. All right, so yeah, that's definitely it. If you do you have any questions, please ask me right now and I will answer them. Is that possible in Engine 1, the C++ component? It already has C++ component system. So you can write your code using C++ and don't use C# at all if you want. Thanks. Thank you for coming. Yeah, you can create a C++ project. For the sake of demo, and because it's much more native for Unity devs, I just wanted to show how to use it with C# component system. Appreciate very much. Thank you, thank you. Any more questions? I think we can spend like 5 more minutes answering them, and then we will end this live stream session. So I think we don't have any more questions. Alright then, so thank you for coming, and please suggest more topics in the comments below, and we will see you next stream. So yeah, thanks for coming and learn UNIGINE. Alright, so my name is Andrei Viktorov and I was your host for today, so bye bye.